Hello, I'm Dr. Deepthi and we are looking at different concepts from maths. The heading under which we are looking at these concepts is Decreations Mathematics. In the recent episodes, we have been talking about the broad topic of linear algebra. Last two episodes were devoted to the concept of basis. So in one of the episodes we had seen what a basis is, and in the next episode we had seen different examples. So now we know that a linearly independent spanning set for a vector space is called its basis. Now the concept linked with basis is dimension. So now let us look at the dimension of a vector space. Consider a vector space V which has a finite basis, that means having finite number of vectors. So here what would be the dimension of the vector space V? The number of vectors in the finite basis is the dimension of vector space V. Let us illustrate this further with an example. Consider the vector space R3, the 3 tuple. Standard basis for R3 is given by the vectors E1, E2 and E3, which is 1, 0, 0, 0, 1, 0, 0, 0, 1 respectively. So here in this case, what is the dimension? What is the number of vectors? 1, 2 and 3. So the dimension is 3. This concept is pretty simple. You can try to extend it to n tuple. So let's say if you consider R2, there are 2 vectors, 1, 0 and 0, 1. So the dimension is 2. We have already seen that the dimension is 3 for R3. How about R4? There are 4 vectors, E1, E2, E3 and E4. So the dimension is 4. So it is pretty straightforward and logical to see that for R raised to n, the dimension is going to be n. So far so good. The concept of dimension is clear. Now next, we have some properties. If you recall, when we talked about basis, we talked about the linear independence, it being a spanning set, and the third thing we had said is the basis may not be unique. For example, we had also seen the example of R3. There were 2 sets of bases that we had seen. One was the standard basis of E1, E2, E3, and another basis of 3 vectors V1, V2, V3, where the vectors were 1, 1, 1, 1, 2, 3 and 2, minus 1, 1 respectively. So the basis here is not unique, or there are 2 bases, which is the plural for basis. But what do you notice? You notice that the number of vectors in each of the bases is identical, which is of course 3. So dimension is identical. Even if there are different bases for a vector space, the number of vectors or the number of basis vectors is identical, and that is the dimension. So we have 2 results. Every basis for a vector space V contains identical number of vectors, and the dimension, that is the number of basis vectors, is unique, even though the basis itself may not be unique. So this is the idea of dimension. Thank you.